Okay, let's talk about significant digits and what that means. When you look at a number or a measurement, the digits that you have read off of a tool, that were actually digits, meaning numbers that you read directly from a meter stick, a graduated cylinder, a balance, any kind of tool that helps you measure. If you read that number directly off of that tool, then that digit is significant. There's also going to be one estimated digit that is also significant. Okay? Let's look at what I mean by this. Here's a ruler, a centimeter ruler that I've just drawn. So it's not like perfect, but just go with me on it. If I'm going to read the length, I'm going to measure the length of this line using this ruler, then I can read that it's 1, 2, 3 centimeters, and then I'm going to estimate the digit between the last lines that I have. Okay, so I'm going to estimate that this is about 3.7 centimeters. If you were to read it, you might estimate 3.8 or 3.6, but it's going to be somewhere in that range. This last digit of a number is always an estimated digit. You're always going to estimate the last thing. So if you're going to read everything you can, and then you're going to estimate one more. If I were to use this ruler, right, now I'm not measuring in centimeters, I'm measuring in 100 centimeters. Of course, it's not to scale. So I know that this line is 100, 200, 300, and then I'm going to estimate about 60 centimeters. So I could read from the ruler 300, but the 60, the tens place, I had to estimate. So this digit right here is estimated. But that makes both of these digits, I read it and I estimated it, significant. Okay, if I look at this ruler, now I have the centimeters, but I also have the markings for tenths of a centimeter. So when I'm reading this ruler, I know that this is 1 centimeter, 2 centimeters, 3 centimeters, 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, 3.7, 3.8, and a little bit over. So I'm going to measure 3.8. I'm going to read that directly off. I'm going to say it's about 3.84. You might have a different opinion. You might say 3.83 or 3.85, but it's going to be somewhere in that ballpark, centimeters. So that makes this digit and this digit the ones I read, and this digit is also significant because it's the one I estimated. But anything that came behind it would not necessarily be significant. Okay, so let's look at the rules. How can we tell when a number is significant and when it is not significant? First, all non-zeros are always significant. Okay, they're always significant. So 3.78 has 3 significant digits or significant figures. You'll see them abbreviated SD or SF. Okay, 523 has 3 significant digits. 1,872.83 has 1, 2, 3, 4, 5, 6 significant digits. All embedded zeros are always significant. Always. If it's embedded, it is significant. Okay? What do I mean by embedded? I mean surrounded by non-zeros. So, for example, 1003. These zeros are surrounded by non-zeros, right? They come between two non-zeros. So that makes them significant. I have 1, 2, 3, 4 significant digits. The number 2.083. These, the 2, the 8, and the 3 are non-zeros, so they have to be significant. The 0 is surrounded by others. It's embedded, so it's also significant. So again, I have 4 significant digits. The number 523.00005, all of the non-zeros have to be significant, so I have 4 of those. And these zeros are in between non-zeros, so they are also significant. So that means I have 3, 4, 5, 6, 7, 8 significant digits. What about zeros that come somewhere other than in between non-zeros? If it is a trailing 0, meaning it comes at the end, then it is significant if there is a decimal. Okay, so 2.0830, all the non-zeros, the embedded 0, and the trailing 0, because there's a decimal, are all significant. 1, 2, 3, 4, 5. 5 significant digits. 1,000, if there is a decimal written behind it. 1, 2, 3, 4 significant digits. 35.0700, right? Non-zeros, those are always significant. Embedded, always significant. And these, there is a decimal, so that makes my trailing zeros significant. So I have 1, 2, 3, 4, 5, 6, 7 significant digits. If there is no decimal, then it is not significant. Okay? If it's a trailing 0 and there's no decimal, like in just the number 1,000 with no decimal, then these are not significant zeros. Only the non-zero is significant. So I have 1 significant digit. 35,070, right? 35,070. The non-zeros are significant. The embedded 0 is significant, but the trailing 0 is not, because I don't have a decimal. So I have 4 significant digits. 2,300. No decimal. Trailing zeros are not significant. So that means only those 2 non-zeros are significant. Whoops, sorry about that. Leading zeros, zeros that come in front, is never significant. Never, ever, ever is a leading 0 significant. Okay, move this out of my way. So, for example, if I have 0.052, it does not matter that there is a decimal. Leading zeros are never significant. So the ones that come in the front are not significant, but the non-zeros still are. So I have 2 significant digits. Okay. If I have 0.000320, okay, my non-zeros are significant. My leading zeros are never significant. The only one I have to think about is this trailing 0. I have a decimal, so it is significant, and I have 3 significant digits. You hardly ever see a number written like this, but if you had 35,000 written this way with a 0 in front, that leading 0 is still not significant. The non-zeros are. There's no decimal, so my trailing zeros are not significant in this case, and I have 2 significant digits. So in summary, there are 2 things that are always significant, right? Non-zeros and embedded zeros. Okay? One thing that's never significant is leading zeros. And there's one thing that's a sometimes. Sometimes trailing zeros can be significant. If there's a decimal, then yes, it's significant. If there's no decimal, then no, it's not significant. Okay?